You're welcome to the second question of the JAM 2020. This is really gonna be interesting. Let's go straight to the question, which says two objects, one having 3 times the mass of the other, are dropped at the same time from a tall building. When they are above the ground, the two objects will have the same. We're given the options, okay? But before we go to these options to know which is correct and which is not correct, let's quickly break down the question, okay? So we're told that they were dropped from a tall building. Two objects. We will assume that they are round. So and we're also told that these two objects, one is 3 times the mass of the other. So let's say the heavier one is 15 kg, while the smaller one is 5 kg. That is 3 times less than the heavier one, all right? And there are some things that were constant. We need to mention those things that is constant. Then in the answer as well, we're told to look for what is constant, what they have as equal, all right? So we're told in writing the question there that time is constant, all right? Then the height, okay, from the top to the bottom, let's assume this is the floor, okay? The height also is constant, of course. What else could be constant? The speed is constant. What else? If the speed is constant, the velocity will be constant. Why is all this? We are looking at a situation where there are no external factors, interference of other external factors. That is to say, there is no air resistance. All right. So this particular question is really interesting because I've seen so many answers, so many websites choosing the wrong answer. So I'm so very much interested in this. If you've seen this before, I'm sure you already have a notion of, oh, it is this. Let's go into the question proper. So the first option, momentum. What will be the momentum as soon as these two objects, they are falling, okay? If you go back to the question, it says when they are above the ground. That means they are still above the ground. Above the ground, they've been dropped. You see, dropped is there in the question. So it is not like they are still hanging, all right? So option A for momentum. What is the formula for momentum? Do you still remember? Okay. P equals, which is equal to mass times velocity, mv. All right. So if in the first instance of the heavier object where we are 15, we say 15 times the velocity which we say is constant, okay, the velocity is constant, and for the second object 5 kilogram times velocity, which is constant. So tell me now, which one would they have the same momentum? No. The object, the heavier object, will have more momentum than the smaller momentum. So answer option A is incorrect. What about answer option B, kinetic energy? From the formula of kinetic energy, which is equal to half mv squared. You still remember? Good. So constant velocity, two different masses. The heavier object will have a higher kinetic energy than the smaller object. So answer option B is incorrect. Answer option C, the potential energy. The formula for potential energy is simply mgh. Okay, I wouldn't want to go much into the details of the explanation, but let me just quickly define potential energy. Potential energy as the energy an object holds relative to its vertical position. It increases as either the height or the mass of the object increases, or both. So in this instance, the height is the same. Okay, the height is the same. So, but the mass is not the same. All right, the height is the same, the mass is not the same. The gravity, the gravitational pull is the same. All right, in this instance, remember we're talking about no air resistance. So if the heavier object has a higher mass, it means that it will have more potential energy than the smaller object. And mind you, they are in motion. The potential energy we're talking about is the gravitational potential energy. Okay, good. So answer option C is not correct, and in most cases I've seen that the answer option C is the chosen option. So we want to dive into option D and to say acceleration is correct. Of course, acceleration is independent of the mass we drop and is a constant. We actually they fall with the same acceleration, so both of them reach the ground at the same time. It is very interesting. There is a video link in the description. If you watch this video, you will be marveled. Like in the case whereby you see an experiment that was done, a live experiment explaining this particular phenomenon in this question. It is amazing. It is so metaphysical, it is so real for you to imagine that this 15 kg object and 5 kg, in fact it's not even up to this, an object that is maybe probably up to like 50 kg, you can imagine like a bag of cement, and just a feather, imagine just one feather of a bird, both falling at the same time and hitting the ground at the same time, where we have all of this constant, no air resistance at all in this particular experiment. It's a live experiment. I will encourage you to watch. Click the link in the description. I'm going to leave that. Click it and watch the video, and we'll see you in the next question. Bye for now.